By the end of this lesson, students will be able to identify the structure of an alpha amino acid, explain the formation of Zwitterions. Amino acids have two functional groups, the amino group and the carboxyl group. Click on each of the buttons on the right to view the names of a few amino acids. Summary. Amino acids have two functional groups, the amino group and the carboxyl group. The simplest amino acid is aminoethanoic acid or glycine. Amino acids are crystalline substances with high melting points and boiling points. They dissolve easily in water but not in nonpolar solvents. The physical properties shown by amino acids clearly reflect their ionic character rather than the covalent nature of most organic compounds. The structural formula shown is not accurate as it shows an acid and a base within the same molecule. These two functional groups undergo an intramolecular acid-base reaction. Click on the carboxyl group. The carboxyl group loses a proton, giving a carboxylate ion, and the amino group is protonated to an ammonium ion. The structure formed is called a dipolar ion or Zwitterion. Amino acids are high melting solids because they crystallize as Zwitterions. Amino acids are amphoteric in nature. They can act simultaneously as an acid or a base depending upon the conditions. Click the plus acid button. In aqueous acidic solution, the Zwitterion acts as a base and accepts a proton to form a conjugate acid. Hence, the H+ ions are removed from the solution. In a strongly acidic solution, all amino acids are present primarily as cations. Click the plus base button. In aqueous basic solution, the Zwitterion acts as an acid and releases a proton to combine with hydroxide ion to form water. In strongly basic solutions, amino acids exist as anions. The concentration of the dipolar ion is at its maximum at some intermediate pH. This pH value is called the isoelectric point. Each amino acid has a particular isoelectric point. Differences in isoelectric points can be used to separate mixtures of amino acids by electrophoresis. Click on the mixture of amino acids. Now, click on the switch. Arginine has an isoelectric point greater than the pH of the solution. It has an overall positive charge at this pH and thus migrates towards the cathode. Aspartic acid has an isoelectric point less than the pH of the solution. It has an overall negative charge and thus migrates towards the anode. Alanine has an isoelectric point nearly equal to the pH of the solution. It has no overall charge and thus does not move. Summary. Amino acids are amphoteric in nature. In the solid form, amino acids exist as dipolar ions or Zwitterions. Each amino acid has a particular isoelectric point.